Hello everyone. Kigo has really hyped me up, but my name is Lillian, as you've heard. We are actually colleagues with Kigo. We are both data scientists, senior data scientists, and I'm really happy to be here. I'm really happy to see all of you guys, and it's actually a privilege to be presenting to everyone here. It's a Saturday. I know people probably have things to do, but you've chosen to be here. So I don't take it for granted. I'm very grateful. And I hope that we will both learn. Um, I don't think I have all the knowledge. I'll share what I know, and we'll all learn together. So if you have any questions, please feel free to stop me in the middle of the presentation. You can just raise your hand, and then I'll take the questions. Or if there's something that maybe you want to pick out from the presentation, just let me know. But I'm really happy to be here, and I'm now going to start the presentation. I don't know if you guys can see my screen.
Yes, we can see it, or I can see it.
Okay, awesome. Awesome. Okay, so as Kigo introduced, we are going to talk about data transformation. And on this, we are just going to discuss on data preprocessing, exploratory data analysis, and eventually we are going to look at data communication concepts. I know that these are very wide topics and we'll probably not be able to handle all these topics conclusively, but we'll just touch on the main concepts, and I'll be able to share with you the slides. And I also have like a detailed document that I worked with. I'll also share that with you guys, and you should be able to now go through it. But I'll try and touch on the main concepts. So just a background. So data preparation is a very critical step in any data science task. It's the initial stage, and you should be able to do data preparation before embarking on any other data science tasks, be it advanced analytics or model development. This is the first thing you need to do, because you find that the data we find in the world is very messy. Sometimes it's incomplete or it's erroneous. So if you use the data as is, then you will not have the right results. You might end up compromising your results by giving erroneous conclusions or even developing unreliable models that are telling people this is what is going to happen, but then in reality, it's not what is going to happen. So you need to be very careful to prepare your data before you can start the steps of advanced analytics or model development. So when you look at data preparation, it's actually the foundation of any data-driven process. Because if you don't have data, then there's nothing you're really doing going forward. So you need to have the data, and then you need to prepare it and make it clean. Then you're able to now move on to other steps. And for data preparation, I don't think there's a way that is set on stone on how you're supposed to do it. It really depends on the context you're working on. It depends on what are you trying to achieve? So what's your end goal? When you understand that, then you will know what kind of data preparation steps I need to follow. At the bottom here, this visual here, it's just a sample of data preparation steps that someone can follow. And the ones that we're focusing on, as I've mentioned, is data preprocessing and exploratory data analysis. We'll also look at data communication concepts, which comes at the complete end. Because for any task that you do, at the end of it, there's someone who asked you to do this task, and you need to present back the findings of your task back to these people. It can be executives, it can be your technical colleagues, it can be anyone really. So you really need to understand how to present your findings in a way that will be impactful, and that's what we'll try and do at the end. So based on the introduction, these are the main objectives of our presentation today, and it's understanding what data processing is. Then we move on to the steps that are there in data preprocessing, and the ones that we're going to look at today are data cleaning, data transformation, integration, and data reduction. We'll then move on to understanding what exploratory data analysis is and what its significance is. So from here on, I'll probably just say EDA because it's a mouthful. So I'll just say EDA. When I say EDA, just know that I'm referring to exploratory data analysis. Then we'll also understand the components of EDA. What do you do when you're doing EDA? Then now we'll move on to data communication concepts, and we'll look at effective communication of data findings, data storing, and data visualization. And we'll also touch on the presentation strategy. So are you going to use oral presentation? Are you going to use written reports? What are the pros and cons of each one of them? So moving on to data preprocessing. What is data preprocessing? So this is a very vital technique in data science, and it's used to convert raw and defined data into clean and usable data for analysis. So as I mentioned earlier, raw data that is collected from various sources in the real world, they are often very dirty. In school, I know that we are always given that data that is very clean and it's very easy to work with, but that's rarely the case in the real world. So the data that you find out here, it's very messy, it's incomplete, it has a lot of errors because of maybe human entry or issues with the systems that are sending this data. So you need to find a way of processing this data before doing any analysis. And if you don't do that, then it's going to impact on the accuracy and the performance of your data analysis and machine learning algorithms. So the key challenges, there are three main challenges with raw data, and that's missing data. And this arises from collection problems such as system glitches, data entry errors, or even biometric issues, or any other issues that might cause data to be missing. Then you have noisy data. And noisy data is just data that has a lot of errors, it has outliers, and outliers mean points that are not normal or they don't conform to what the other points are showing you. It can also just be meaningless information stemming maybe from human mistakes, exceptions, or mislabels. And finally, we have inconsistent data. And this is whereby you have similar data stored in different formats. So for example, you can find that maybe in a data set, we have gender. So one person enters female, another person enters F. So that's inconsistent, and this will impact your analysis. So moving on to the data preprocessing steps. As I mentioned, there are 4 of them that we are going to tackle today. So there's data cleaning, and this is where we try and fill in missing data. This is now dealing with the missing data part. Then we move on to smoothing of the noise, and this corrects the noisy data that we discussed. And finally, we can rectify inconsistencies in the real world data, which is a problem of the inconsistent data. Then we move on to data integration, and data integration just basically means merging data from different sources. Most times when you're doing your analysis or when you're developing your algorithms, you'll find that you'll not use data from just one source. You'll probably need to match different data sets. So you'll need to find a way of integrating these data sets together and working with them in a way that is correct. So that's what we are talking about here. And when you bring in 2 data sets or even more together, you'll find that you might have redundancies. And redundancies here mean I have like a point on one source and it's repeated on this other side. So what's the point of having both? So maybe here I'm just calling customer address as customer address, and then on this other table I'm calling it home address. Those are 2 same data points. So we need to be able to get rid of redundancies and inconsistencies. Then we move on to data transformation, and this just means streamlining our data for efficient mining and also making it easier for us to find patterns in that data. And there are several strategies of doing this. And finally, we have data reduction, and this is just making our data set a bit smaller so that it's a bit easier to work with. So those are the 4 data preprocessing steps that we are going to look at. So now we'll move on to data cleaning. And in data cleaning, we are going to discuss how to handle the 3 key challenges you find with raw data. So the first one is handling missing values. So what do you do when you have a lot of missing values? You'll first need to look at your data set and see how much missing values do I have? Is it too much? You can even create a threshold, and for a certain column, you create a threshold and check. Say if this column has 40% of its, or 40 or above percent of its data missing, then ideally, maybe even trying to fill in those missing values, we might make mistakes. You might decide to drop it if it does not really impact your analysis at the end of the day. So there are different strategies of handling missing values, and we are going to go through them. So the first one is deleting rows with missing values. This is a strategy that can be used, but I think it's not very ideal. Why? Because you're losing data, which can be very beneficial for your analysis. So you can delete rows with missing data, but you need to be very careful and understand your concept. Do I have enough data to continue with my analysis such that if I delete these rows, my subsequent analysis and insights and findings will not be affected before you delete any data, but it's one of the ways you can do it. Then the second one is imputing missing values, and this just means replacing missing values with a certain figure. And here it can mean you replace it with a constant figure. This is for the numerical values. You can either replace it with a mean, you can replace it with a median, or with a mode. When it comes to categorical values, you'll not be able to find this, of course. So for categorical values, what do? You will probably look at all the categories that exist, and then you check which is the category that is appearing the most. Then you can decide to input your missing values with that category. But if you are to go through your missing data and you find that there are a lot of data points missing and it's a category, then you can also decide to just come up with your own category to replace those missing values. Then we move on to advanced imputation methods. And this just means that you don't use the imputation methods we have discussed. So here you can decide to use whatever imputation method works for your data set. And this can either be, there's one that is called last observation carried forward. And last observation carried forward, this means we use the last valid observation to fill in the missing values. So the value that you're using to impute will not be the same across. It's going to be different because you're using the last observation carried forward. There are other imputation methods like forward filling. So you use the value that is before after the value that is missing. So that's forward filling, and then there's back filling, which you're using values that are before the value that's missing. So there are very many other imputation methods, so it just depends with the context. Then you can also choose to use an algorithm that is robust to missing values. There are certain machine learning algorithms that can actually work even if you have not replaced missing values. And some of these algorithms are like the random forest. So it depends with what you're trying to achieve. And if maybe random forest will work for you, then it's robust to missing values and it will still give you good results. And then lastly, you can predict missing values using the other features that already exist in your data set. So this is actually very good because you're just not replacing with whatever figure, but you're actually predicting based on the features that I already have that are not missing, what will be this value that I have missing. So those are the different ways of handling missing values. Then we'll move on to addressing noisy data. And noisy data, as we had talked about, it impacts accuracy. And types of noise can be unknown and uncoding. So you find that maybe for someone, for a database where we are putting marital status, someone can decide to use value Q, which is not F or M or whatever other values that's in the database. So types of noise can be very different, and there are several ways of treating this. And we are going to discuss binning and smoothing. So binning and smoothing just means you sort your data that you already have into bins or buckets, and then the bins and buckets are created by equal distance or equal depth, which is the frequency. And then you smooth these bins by replacing them either by means or the median or the boundary. And I know this sounds very it's not probably very clear, but I have a visual on the next slide that will probably show you how this is done. And it ends up reducing the noise in the data. Then on noisy data, we can also treat our outliers. So outliers are just any observations given in a data set that lies far from the rest of the observations. So these values will probably be vastly larger or smaller than the remaining values in a set.
Lillian, you're on mute. Sorry.
I'm so sorry. I don't know if you guys can hear me now.
Yeah.
Okay. Sorry, so I was discussing outlier analysis, and I was talking about how you can detect outliers. And I think the best ways of detecting outliers is using box plots. And I don't know if everyone is familiar with them, but in another slide, I'll just show you how a box plot looks like and also how you can detect outliers using a box plot. Ideally, it's like a representation of the distribution of your values, and if a value falls outside a certain range, then it's deemed as an outlier. And as I've said, it's an actual value, so it's not really an error. So maybe you actually need it in your analysis because it might happen again. And for your algorithm, you probably need to make it robust such that if it was to happen again, it gives you the correct figures. So the treatment options for outliers is the first one. You can either decide to actually remove the outliers completely. You're not removing values that will help your analysis or that will make your algorithm same as if it's below the 10th percentile. So it's very small. You need to replace it with a factor that has been capped if it's below the 10th percentile. So that's another way of dealing with it. And then the other way is you can either use a mean or a median to impute the outliers. But as I said, this is it's just an overview of how you can do it, but it really depends on your data, and you need to understand your data for you to make the best decision. We finally move on to inconsistent data, and correcting for inconsistent data will mean that you use your domain knowledge or expert knowledge to know what do we need to replace it with. And I find that working with, say, the business that provided you with this data, being a very good way of knowing what to replace it with. Because let's say we are working with customer data, and then you find that there are certain values that have not been put correctly for this customer data. As a data scientist, you're a technical person. You might not really understand what do I need to replace this with. So if you work with the business closely, they have expert knowledge and domain knowledge to tell you, oh, For this one, we actually collect this information, and ideally, this is what it's meant to be as compared to what has been put there. I hope that's clear. So for the correcting of noise using binning, this is what I was talking about. So the first thing you do is just sort the data, and here we have some price data. So you sort it from the smallest to the largest, and then you end up partitioning it at equal frequency, and here we are doing three values. So we have 4, 8, 15, 21, 21, 24, and so on. Then now you can come here, smoothing by means. So you just calculate the mean for each bin. And for bin 1, the mean is 9, and you replace it with 9 for each value. Then bin 2, it's 22, you replace it with 22, and you continue with all the bins that you have. You can decide to use smoothing by means. You can use smoothing by median. So here for bin 1, the median would be 8. So you'll just replace it with 8. For bin 2, the median would be 21. So you replace it with 21. And finally, for bin 3, it's going to be 28. You replace it with 28. Then there's another way of replacing it, of smoothing using bin boundaries. And for bin boundaries, this just means you use the boundaries of the bins to replace it. So there's the lower boundary and the upper boundary, and the lower boundary is the first value in that bin, and the upper boundary is the last value in that bin. And then now you replace values in the bin using either the lower or the upper boundary, depending on how close your value is to the boundary. I don't know if that is clear. So like for bin 1, 4, it's the lower boundary, so it just remains. But when you look at 8, 8 is closer to 4 as compared to 15. So you replace it with 4. And that's why the middle one is 4. And then 15, it's 15. Then for the second one, there's not much changes because it's 21, 21, and then 24. Then for bin 3, you see that it's 25, which is the lower boundary. Then you look at 28. Is it closer to 24 to 34, or is it closer to 25? And it's closer to 25. So you just replace it with 25. And that's what I meant by correcting of noise using the binning method. I hope it's a bit clearer after this. So we are done with data cleaning. We now move on to data integration. And this is what I just said. It's merging data from different data sources. And the aim here is to make sure that we are reducing and avoiding redundancies and inconsistencies in the resulting database as much as possible. And there are several tasks that you can do in the integration step. So the first one is the entity identification problem. And ideally, what this means is, how do we know, or how can we match entities from multiple data sources where the names are not the same? How are we able to know them? And the best way of doing this is to use the metadata for each attribute to avoid errors. And the metadata for each attribute can mean the name, so like the name of the attribute, then the data type or the description. So I'll use an example of, let's say customer data. I think it's the easiest to understand, or even let's say product data. So we can have product name, which is the name of the attribute. Then the description will probably just be, this stores the product names of the products in our database. Then we can have the data type, so it will probably be a string. Then the range of values permitted. There might not be a range because this is a string. So all these metadata will help you identify if certain attributes from one system will match up with attributes in another system. And therefore, you'll make sure that you're not having errors or you're not having redundancies. So that's the entity identification problem. And the best way to resolve it is to use the metadata for each attribute to understand them and to see whether we have redundancies. We move on to redundancy and correlation analysis. So redundancy and correlation analysis is just meaning that an attribute might be stored in two different data sources if it can be derived from one. I don't know if that makes sense, but let's say we have daily sales in one database, but in another database, we have annual sales. So when we bring them together, we have daily sales and then we have annual sales. But ideally, we can derive annual sales from daily sales because we'll just need to multiply daily sales by 365. So we are being redundant here. So you just need to understand, do we have redundancies? And when you find redundant values, you don't need to keep both of them. You just need to drop the ones that you don't need. So that's redundancy and correlation analysis. Then we move on to detection and resolution of data value conflicts. And this means so data integration involves the detection and resolution of data value conflicts. For example, the same real world entity, the values might differ from different sources. And an example that I would give here is, let's say we are dealing with a chain of hotels that are based in different countries and we're looking at their prices. So let's take an example here of, say, Radisson Blu, which might be a chain of hotels that's in Kenya, it's also in Tanzania, it's also in Uganda. And we're trying to analyze the regional data. But in Kenya, we'll have the prices in Kenya shilling. In Uganda, we'll have the prices in UGX. You need to be able to harmonize such that all these prices are in the same currency so that we don't have any issues. Because here we might be saying a room per night, it's 10,000 shilling, but in Tanzania, we are saying it's 500 TZS. So you see, there'll be issues there. So you just need to harmonize and know what do we need to do. And if I have price on this source and price on another source, are they using the same metrics or do we need to do any conversion? I hope that's clear. Then we move on to data transformation. So data transformation, this means we change our data in a way that it will make it easier for us in the mining process, and it also makes it just more efficient and easier for us to find patterns in our data sets. And there are several ways of doing transformation. It's not limited to the ones that I've said here. So smoothing is what we have already discussed in the removing of noise from data, so I'm just going to skip that. Then we have attribute construction. So attribute construction just means creating new features based on attributes that we already have. So you might start doing maybe your modeling and you find that you probably need a bit more features. So you can just try and create new attributes based on what you already have. Then we move on to aggregation, and aggregation just means summarizing the data at a higher level. So like, let's say we have the sales per county, then we can just now aggregate and have sales at a country level. So that's what aggregation means. Then there's normalization, and this is where an attribute is scaled so as to fall within a smaller range. And it can also just mean changing up our data set such that the different attributes we have, the values are not very varied. So like, let's say you have one attribute and the values are in millions, and then you have another attribute and the values are probably decimal points. You might start getting issues, especially in modeling. So you will probably need to normalize and standardize so that your models work correctly. Then we have discretization, sorry. And this is where the raw values of a numeric attribute are replaced by intervals. So like, let's say for age, instead of having 21, 24, 30, you just create bins. So you say if your age is between 0 and 10, this is where I fall, 11 and 20, and so on. And it can also just mean creating categories. So you can say if you're between 0 to 25, then you're a youth. If you're between 25 to 35, you're something else. That can also be the case. And finally, there's concept hierarchy generation. And this is for nominal data where attributes like street can be generalized to higher level concepts like a city or a country. So that's just what it means. So we move on to data reduction, and this is the final step in data processing. So we have several things we can do on data reduction. And ideally, we do this because when you're doing data analysis on large data sets, it can be very time consuming and also resource intensive. And sometimes it can even become impractical because you probably don't have those resources or you don't have that time. So data reduction methods just helps us create smaller, but they have to be representative of the entire data set, such that if I am coming with a conclusion on this smaller data set, if I was to run the same analysis on the bigger data sets, they should be very, very similar. That's what you need to remember with data reduction. If it's not a representative, then you'd rather not do it because you will end up with analysis or conclusions or findings that are not correct and they are not representative of the entire population. So that's what you need to remember with data reduction. So there are several strategies that you can use for data reduction, and there's feature selection. So feature selection just means that we are using a subset of the entire features we have for our data set, because sometimes you find there are data sets that actually carry the same information. So why do you need to keep both? You just look at the one that you probably want to use and you drop the rest. Then there's feature extraction, and this just means transforming the data into a lower dimensional space, but still preserving the most important information. And if you're familiar with PCA, I think PCA is the one that's used to do this. It just transforms your data into a lower dimensional space. So PCA is principal component analysis. Then there's data compression, and data compression is just compressing our data set while preserving the important information. And compression is used to reduce the size of the data for storage and transmission. That's mostly why it's used. Then there's sampling, and sampling is used to reduce our data because it allows a large data set to be represented by a much smaller random sample. So there are different ways of doing sampling, and it depends with the context that you're working with. So you can either use random sampling, stratified sampling, systematic sampling. So you can use any of those sampling techniques based on what you want to achieve and the context that you're working on. So that's for data processing. I don't know if anyone has a question. I don't know if anyone has a question, or do we move on?
I think we can proceed and then take questions at the end.
Okay, awesome. Okay, so let's now move on to exploratory data analysis. So exploratory data analysis is just the process of performing initial investigations on your data so that you can better understand your data, you can discover patterns, you can see anomalies that are existing, you can test hypotheses, or even you can check for assumptions based on what you already know. So EDA is a very critical step because you don't want to dive deep into advanced analytics or model building without first just getting an understanding of your data. So it's a very, very critical step. And there are several benefits of doing EDA. And the first one is you're able to identify the most important variables or features in your data set. It also allows you to test hypotheses and check assumptions related to the data set. It also helps you to check the quality of your data for further processing and cleaning. This is probably after you've done data pre-processing, and you can just confirm whether everything that you were meant to check for is now okay. Then it can also be used to drive insights to business stakeholders because you might discover things at that level of just EDA that is actually important to business stakeholders, and you can actually share this with the stakeholders even before going further. Then you can verify expected relationships in the data. There are some things when you're already getting into your data, you know that this variable has to have a relationship with another variable. Like let's say if you're looking at car prices, then you will probably go in with the expectation that there'll be a relationship to how expensive a car is and how old it is. So you're going in expecting there's a relationship. So you can verify the expected relationships, and you can also use this process to discover the unexpected relationships. Because sometimes you get into the data and you find relationships that you did not expect to be there. So EDA helps you to do that. And finally, it helps you find the unexpected structure or insights in the data. So there are several components of EDA, and the way I look at it is the ones I've listed here, but it does not have to follow this process. It doesn't have to be this component. You can choose to use a different way, but as long as you're just making sure you're understanding your data. So the first one is understanding the big picture. And understanding the big picture is looking at your data in its entirety. So we are not looking at the data in a variable by variable. So we are checking for, say, what are the variable names? Are these variables categorical? Are they numerical? Is it a Boolean? So you're just understanding this data set. And then you can also check the importance of the variables based on the domain knowledge that you're already coming in with. So that's just looking at the big picture. Once you have an understanding of the data set in its entirety, we then move on to data validation and further cleaning. So here, because you've already probably done pre-processing, your data will be clean, but it does not hurt to validate that it's actually clean. And if it needs further cleaning, you can do it here. So you check for missing values, and you find missing values, you can decide to use the strategies we discussed earlier to handle those missing values. Then we can also validate the variable data types. And if you find that there's a data type that is mismatched, like let's say we find age has been put as text, or something that's very common, date has been stored as string, then you convert them back to the formats that they're supposed to be. Then at this point, you can also eliminate redundant variables in case you missed to do this when you're doing data integration. And finally, you can check for outliers, identify them, and address them based on the strategies we discussed. Another thing that is important to do here is to check for duplicate values. You can find that sometimes there are duplicated entries in your data set, and it's very important for you to check whether there are any duplicates. And if you find duplicated values, then ideally you just need to drop them because they carry the same exact information as another row in your data set. So you don't need to have both. So you just drop them. Once you have validated your data and you've cleaned, then you now move on to understanding the variable. And here, as opposed to the first step, we are looking at the variable as itself. So we are looking at the individual's variables as themselves. And you can here use visuals such as histograms. And histograms ideally are just used to represent the data frequency with bars. And you can also use box plots, which depict the data distribution using boxes. For categorical values, we try and understand how many categories do we have and what is the distribution of these categories. So one of the things that is very important when you're understanding categorical value, especially if your target variable, the thing that you're trying to predict, is a categorical variable, then looking at the distribution is very important because you find that some data sets, the it's going to be imbalanced. So one category is much, much higher as compared to another one. And I think this is very common when you're looking at fraud cases, because in the real world, there are probably not that many cases that have been classified as fraud. So you will have cases which have been classified as not fraud, being way, way high as compared to the ones that have been classified as fraud. So you'll find that your data set is imbalanced. And this is something that you will need to address before even moving on. Because if you don't address it, then it's going to still give you issues. Then for numerical variables, we need to understand the summary statistics and check for the distribution. So is it normally distributed? Does it have any skewness? And also just check for the summary statistics. What is the minimum value? What's the maximum value? What's the mean? What's the median? All those good things, you'll be able to do it when you're looking at a variable one by one. So here we are looking at a variable one by one. In the first part, we are looking at the data set in its entirety. Then finally, we understand the variable relationships. So how does one variable relate to other variables? And this is what we do here. And there are different techniques to use. So there's the correlation matrix and plots. So this is very important to do because it shows you the variables that are highly correlated. So if the correlation coefficient is closer to 1, then it means that these values are positively correlated, highly positively correlated. So it means as one variable increases, the other one increases. And if it's closer to -1, then it means they're increasing, the other variable is decreasing. So used to identify relationships and outliers. So they'll actually show you even whatever we've talked about correlation, because you'll be able to see it, and even other relationships in the data set. A scatter plot is very good at that. Then we finally have the pair plot, which is just a scatter plot for all the variable pairs. But with a pair plot, you need to be very careful because it's only efficient when you're exploring key relationships in data sets with few variables. So if you have a data set that has a lot of variables, you'd rather not use the pair plot because it's very computationally expensive to compute. So here we just have two figures that will help us just to understand. So the first one here is a histogram, and it shows us the distribution, and it also shows us whether our data is skewed. And we can see for this particular data set, it has some left skewness. Then on this other side, this is the box plot, which is what I had said we'll discuss. So the box plot shows you the distribution of your data set. So the longer the black box, this part over here, so the more varied the distribution. Then we have the upper quartile, which is here. We have the lower quartile, and then we have the max over here, and then the minimum. So if a value is out here or here, then it means those are outliers. And you probably need to understand, why do they exist? Is it an error? Is it a true variable? And if it's a true variable, why did it happen? Is there a possibility of happening again? So this is a box plot, and it's just very good plot that gives you a lot of information. You can also have several box plots in one plot. Like, let's say when you're looking at a categorical variable and a numerical variable, and you're able to compare how it's changing for the different numerical variables, how the distribution is. Then on this side, this is the scatter plot. So it can show you the different relationships that exist between two variables. And as I said, it can also show you outliers. So like you see these value here, it's probably an outlier because it's so far from the rest of the values. Then here, this is the pair plot, which I've said you should be careful when you're using it because it can become very computationally expensive. And it's just a scatter plot of all the pairs in your data set. And then in the middle here, in the diagonal line, so it's just a plot of the variable against itself. So like this one at the top here is price against price. So instead of having a scatter plot, you can just have a histogram that can probably give you more information as compared to having a scatter plot of the same variable. This one will give you the information on how the distribution of that data set is and also its skewness. So now we have finished on EDA and we move on to our final topic of the day. And I would like to start with a story. So on 28th of January 1986, I don't know if you guys know this, but there was a space shuttle Challenger that disintegrated, or it exploded 73 seconds after liftoff, and it killed all the 7 crews on board. And the cause of the explosion were the failure of 2 redundant seals in a joint. And funny thing, or the interesting thing, is that these had actually been detected during testing. Some NASA employees had actually done their testing and they had seen that there's an issue with those seals. And they had communicated it to the executives and they had said, it's not safe and therefore we probably need to do further testing. But how did they communicate it? This slide So this slide at the bottom here is how they actually communicated it. And the highlighted part is how they had expressed their concern. But you see, the problem is how they communicated it, it did not pass the message on how much concern was there or how critical it was. And that's why it's extremely important to communicate your findings in a way that is impactful. Because sometimes you can have the most crucial results, but if you don't communicate it in a good way, then it's not going to have an impact. This is probably a very extreme case, unless you're in the medical field, whereby also if you don't communicate your findings in a clear way, then people's lives are going to be lost. But it just goes to show you that it's extremely, extremely important to communicate your findings in a way that will have an impact and cause change. So that's just, I needed to emphasize on how important it is for you to communicate your findings to executives in a good way. So we'll move on to data storytelling. So what is data storytelling? Data storytelling is a powerful method of sharing insights using compelling narratives and effective visualizations. And you'll ask yourself, why is it so powerful? Why is data storytelling so powerful as compared to just building slides and going and presenting it? It's because anecdotes, they ignite someone's imagination. And when you're telling someone a story, you're sort of having them follow along with you and you're igniting their imagination. And another thing about stories is they're more memorable as compared to metrics. If someone comes here and just gives you facts and numbers and figures, you probably will get tired. But when someone tells you a story and takes you on a journey of how they did their analysis, how they came up with their findings, so they curate it in a way that it's a story, then it's more memorable and it's something that will stick with the people you're presenting it. And finally, it helps contextualize data and it adds value. So data in its raw form might not really do much for you. But when you change it up into a story, then it adds so much value to the people you are working with and the people you are working for. So the impact of a good data story is that it captures the audience attention, it facilitates understanding, and the most important thing is that it drives decision making and spurs action. And most times you'll find that you're working in an organization where people are very change averse. And it's understandable, because if you have something that has been working and maybe it has not been working very well, then why are you trying to convince me to change? So for you to convince someone to change, you really need to have a convincing story. And if they are not convinced, then there's no action that's going to be taken, and your analysis will just go to waste. So there are two concepts that help us build an effective data story, and they help us to articulate our stories in a clear and concise manner. And these two concepts are the 3-minute story. And what this means is, if you're given 3 minutes, what would you tell us? What would you focus on? What is so important in your analysis that you would want to make sure that in those 3 minutes, I have covered these important concepts, and I am sure that whatever I have worked on has actually been heard. And then the other one is the big idea. So here it means what is our story's unique point of view, just in one sentence. So you need to be able to summarize everything that you have been doing in one sentence, and it's something that is unique and it's something that's impactful. So even when you're curating your data stories, you need to keep this in mind so that you don't keep deviating. Then for a good data story, there are 3 central elements to it. And the first one, of course, is data. If you don't have data, then there's no story, there's no narrative, there's nothing. So the first thing you need to have is data. But it's not just any data. Your data needs to be accurate, and it needs also to produce reliable findings and also emphasize actionable insights. And that's why it's very important to do pre-processing and also to do EDA, because you need to work with data that is actually reliable, accurate, and quality. Because as you understand, garbage in, garbage out. So if you put in the wrong thing, of course, you will expect to get the wrong thing out. The second thing is the narrative. So your narrative has to be clear, audience-focused, with a central insight and following a linear sequence. What does it mean to be audience-focused? When I'm creating a narrative for whatever analysis I have been doing, it will probably be different for an executive as compared to a technical team, because executive might not be as technical as the technical team. So they need to be audience focused. You need to switch your narratives based on the audience that you're going to talk to. You cannot just use the same narrative for every single audience you're going to talk to. You need to switch it up. Then when you're talking about a linear sequence, points need to build you need to build your points on each other. So I cannot talk about one thing and then I jump off to another thing that are completely not related. So you need to build on each point so that you eventually land on your key findings or your central insight. And lastly, we have visuals, and visuals are very important because visuals break the monotony of just words and they help people understand better. Because when someone looks at a picture, they probably get more as compared to writing so many words. And I guess that's why we have the phrase, a picture is worth 1,000 words. So when you're using your visuals, you need to remember to use simple, meaningful graphs and avoid misleading visuals. If you don't need to have it, no matter how good it looks, just keep it out. Don't put it in your presentation. So this is how a good data story looks like. So you have data, a narrative, visuals, and in the middle there, we have the data story. Then we move on to data visualizations. So we know visualizations are extremely important in any data story. And there are several best practices to keep in mind when you're coming up with visuals. And these are just a few. I am sure there are so many others, as I told you before. This is a very big topic and it will need a lot to discuss, but these are just some of the components that I wanted to discuss with you guys. And the first one is choose and adjust your visuals. So align the visuals that you have with the message. So you just don't put visuals because you find that maybe it's a bit cool, it shows how technical you can be. You'd rather use something simple. Then you should also consider an audience expertise. So if I am going to present to the CEO, he might be smart and understand some very complex visuals, but you would rather just understand that the audience I'm going to present to might not be as technical as I am. So I need to make it simple. And then select easily interpretable graphs. Graphs that when you just put it out there, someone is able to interpret it even before you say a word. That's what you need to remember. Then prioritize relevance. You should only include those visualizations that are directly linked to our message. Then complexity versus clarity. When you have complex plots, they can actually share so much information, but they can be very time consuming when you're trying to interpret it, and it can even be hard for someone to understand no matter how much you try and interpret it. So what do? You need to find a balance between complexity versus clarity. So simple plots can offer quick understanding but fewer insights. So you need to find a balance between complex plots and simple plots, and where is the sweet spot where you can have more insights being delivered to your audience, but at the same time, it's not very hard to understand. And finally, less is more. Focus on simple, relevant visuals and avoid overwhelming with excessive details. Let your visuals be very simple and relevant and easy for the users to get information from. Then another thing that you need to do when you're preparing for your presentation is to do an audience analysis. And an audience analysis, this means is understanding your audience so that you can create your narratives and your data stories centered on the audience that you have, and just knowing that I am doing it in the right way for this particular audience. So you need to define stakeholders. So stakeholders are just anyone really who's concerned with the project outcomes, and it can be the executives, it can be just a business user, it can be your team members, it can be anyone. Anyone is a stakeholder if they're interested in the project outcomes. And the best way to understand your audience is creating audience personas. And audience persona is just describing a person who has interest in your project, and you can describe the different characteristics of this persona. So it's not really a person who exists, but you're creating it so that you know how to curate it. So you can say, our stakeholder is a business team. They have limited technical knowledge. They have very good domain knowledge. The key thing they would want to understand is how our prices affect the buying power of our customers. So that's how you create an audience performance. And then now when you're going to present to them, you will present different findings to different audiences because they'll probably have different interests in your findings. For a business user, maybe it's going to optimize their processes. For a CEO, maybe it's going to make decisions. So you need to remember that and to tailor your presentation based on that. Then there's something here about audience skepticism, and you need to keep it in mind because when you're presenting to different audiences, some of them will be receptive, others will not be receptive. And it's important not to get offended because you might have put in so much effort and you're wondering, how can this person not believe me? And I have put in so much effort. How can they not see it? But it's important to remember that they can be skeptics. So what do you do in such a case? You should be ready to get more data and get more insights to convince skeptics. And the best approach to follow is to first try and convince yourself. When you're doing an analysis, try and convince yourself to actually believe in the findings and in the actions that you're proposing. When you have convinced yourself, go and convince a friend. A friend will be more lenient to you. They'll be more willing to listen because you probably have rapport, you know each other. They'll be able to listen and you will be able to convince them. And then once you have moved on, you can now convince a skeptic. A skeptic will be a bit hard to convince, but if you have moved on, you probably have a very good selling point and you can convince a skeptic. Then I think for the next ones, we'll just move on pretty fast because I think our time is really moved on. I'm sorry for that. So another thing to remember is the presentation strategy. When you have your data story, you have all these good things. What is the strategy that you're going to follow? And there are three things here to look at, and there's stakeholder consideration, content selection, special requirements, and consumption choices. For stakeholder considerations, you need to identify the audience as discussed earlier. Why do they need these findings? How will they use these findings? Are they going to make decisions based on it? Are they going to start a new project based on our findings? You need to understand how they're going to use your findings. And then finally, what is the information they require? Do they require the results? Do they require the impact? Do they require the methodology we used? You need to understand that so that you can tailor your presentation. Then we move on to the content selection. For content selection, we need to understand, is our audience more, are they more focused on the results, the conclusion, the recommendation, the detailed method? You need to understand that as well for you to select your content. Then special requirements, these are just requirements that might be very specific to a user, and one of them is time. For the person you're presenting to, do they have a lot of time or do they have little time? If they have little time, maybe a PowerPoint presentation is better. If they have a lot of time, then you can share with them a written report. And then also authority. For the person you're presenting to, are they reporting to another person who they need to convince on why they made certain decisions? So if that's the case, they probably need a very comprehensive report detailing why they need to make a certain decision in a certain way. Then time zone constraints. You need to understand, for the people I am presenting with or I'm working with, are they in a different time zone? And if they're in a different time zone, maybe presenting it orally or in a presentation style might not be possible. So in such a case, sharing it in email or in written reports is the best way to do it. Then consumption choices, this just means how do you format it? So for your documents, is it a Word document that's very detailed, or is it just a slide deck? Is that what they prefer? Then do you want to collect your feedback immediately? Therefore, presentation is better because people will engage with you, or do you want to get comments based on a written report? Then the delivery mechanism. You need to understand your audience size, because if I'm presenting to 250 people in a conference room, then my strategy would be different if I'm just presenting to my team members of 7 people in a small meeting room. So you need to keep all this in mind. Then finally, I believe this is the final slide. There are different ways you can present. So there's oral communication and written formats. And you need to look at both their disadvantages and advantages and see which one fits your case. So for oral communication, the main advantages of it is that you build rapport with your audience. When you're speaking with them, you can create a relationship. And when I think there's something about being able to just communicate to people who are giving you feedback immediately when you're looking at them. So you're building rapport. Then it also allows for immediate feedback, because when you're presenting, people can stop you and they can ask questions, they can give comments. So it's very advantageous in that way. And then oral communication conveys rich messages because of body languages, and voice add meaning. Because when someone is conveying something that is very critical, you'll probably see a shift in how their body language is. So you're able to capture your audience when you're presenting to them in an oral manner. The only issue now, the disadvantages with oral communication is that there's no permanent record. If you are wanted to refer back, then you don't have any permanent record, unless now you're doing Teams where you can have recordings. But in this case, we are talking about one-on-one presentations. Then also, it's not very suitable for lengthy presentations because people get bored and their concentration spans go down, and therefore your message will not really have an impact. Then for the written format, the advantages is that it provides lasting records. So if you wanted to ever refer, you have that provision to refer back to what you have, and you are also able to share the knowledge. You can distribute it to other team members, and it can be used in other projects. So those are the main advantages of written format. For the disadvantages, it's limited immediate feedback. Some people will read it and they'll give you comments, and even other times people don't read documents. That's the disadvantage. So a thing to remember is just balance your audience preferences with the format strength, stroke the weaknesses. And I believe that's the end of my presentation. I'm sorry that I've taken more time than I was meant to, but if you have any questions, now is the time you can ask me.